Hi, everyone. This lesson primarily covers detection and judgment of reinforcement corrosion potential, durability issues of reinforced concrete structures, increasingly drawing people's attention, whereas reinforcement corrosion is one of the main factors affecting structural durability. With industrial pollution and the aging of building structures, the issue of rebar corrosion is becoming increasingly prominent, directly affects the safe use of the structure. Next, we will explain by category non-destructive testing methods that are commonly used to determine the corrosion activity of steel bars in concrete. This lesson primarily covers the following 4 topics. 1. Concept of the half-cell potential method. 2. Principle of measuring steel reinforcement corrosion. 3. Measurement instruments and techniques. 4. Rebar corrosion potential judgment standard. Half-cell potential method refers to using the potential changes caused by the electrochemical reaction of rebar corrosion in concrete to measure the reinforcement corrosion state. By measuring the reinforced concrete half-cell electrode with the copper sulfate on the concrete surface, the magnitude of potential difference between reference electrodes to evaluate the reinforcement in concrete. Corrosion activation degree. Reinforcement corrosion. It is an electrochemical process produced during the hydration process of Portland cement. Calcium hydroxide is partially dissolved in the liquid phase of concrete, making the concrete alkaline, pH between 13 to 14. Rebar in an alkaline environment. A dense oxide film forms on its surface, maintains rebar in a passive state. Meanwhile, concrete also provides physical protection to rebar. Then, do you know what causes reinforcement corrosion? What are the main reasons? Carbonation of concrete, typically in the air, contains a large amount of carbon dioxide and acidic gases, which can react with the alkaline components in concrete. Carbonation reduces the pH value of concrete. Calcium bisulfite, calcium sulfate. The dense oxide film is destroyed. Alkali aggregate reaction. When the alkali concentration in concrete, after exceeding a certain pH value, reactive minerals in aggregates such as microcrystalline and cryptocrystalline silica, a chemical reaction occurs to form internal gel, and this gel is often absorbs water and expands. Once the concrete is eroded by water, internal self-expansion of concrete, thereby generating excessive internal stress, causes concrete expansion cracking. Sulfate erosion damage. Calcium bisulfite, calcium sulfate, will react with tricalcium aluminate in cement hydration products. Volume increases, thereby causing concrete to crack. Once localized damage occurs to the rebar's surface passive film, or become poorly compacted, incomplete, then the passive film location becomes the anode, while the surrounding passive film remains intact. Locations form the cathode, thereby forming several microcells. Although some microcells are in an inhibited state, but can be activated under certain conditions, thereby placing it in activated state undergoes redox reaction. This leads to reinforcement corrosion. Macroscopically, concrete and the embedded rebar forms a half cell. It is precisely through inspection of the aforementioned half-cell potential of reinforcement corrosion in an activated state. To determine the activation level of reinforcement corrosion in the current concrete. The detection range for reinforcement corrosion condition should be main load-bearing member, or primary stress-bearing locations of load-bearing members, or locations where rebar corrosion may exist. However, the measurement area should not show obvious corrosion-induced cracking, voids, or delamination phenomena. When arranging test grids on measurement areas, grid nodes serve as measuring points. Optional grid spacing: 20 cm x 20 cm, 30 cm x 30 cm, 20 cm multiplied by 10 cm, etc. Determined based on component size. Measuring point locations shall be more than 5 cm from component edges. Generally, no fewer than 20 measuring points should be used. When readings from adjacent measuring points in a measurement area, one exceeding 150 mV, the spacing between measuring points should generally be reduced. Measurement areas should be uniformly numbered, indicate the location, and describe surface conditions. Properly connect instruments to collect data. Collected data shall undergo temperature correction before interpretation. By convention, these data are assigned negative signs. Interpret after drawing the equipotential diagram. Judgment criteria should follow the potential levels in the table. To determine in the concrete probability of rebar corrosion occurrence, or the corrosion activation degree of ongoing reinforcement corrosion. For example, when the potential level is greater than or equal to -200 mV, can determine the rebar condition as having no corrosion activity or uncertain corrosion activity. Evaluation scale is 1. Through the learning of key points in this task, can indicate the influence of rebar corrosion on the durability and safety of structures. Describing rebar corrosion in concrete. Electrochemical principle. By detecting the magnitude of reinforcement corrosion potential in concrete, preliminary judgment of rebar corrosion status